Okay, let's take a look at scientific notation and computing with addition and subtraction. This uses the prior knowledge that when the exponent moves one place to the right, we multiply by 10, and when the exponent moves one place to the left, we divide by 10. I will show you a method to help understand this. But we do have to know that when you add or subtract in scientific notation, you need to have both of numbers in the same power of 10. So we will need to manipulate one of the numbers' decimal points in order to get the powers of 10 in the same exponent. Here is an explanation of how the exponent raises. This first number is 6,892 times 10 to the 0 power, which is the same thing as 6,892. So I will call this the decimal place is now at home in a normal number. Notice that the exponent increases from 1 to 2 to 3, going from left to right. So if I want to change a 0 exponent up 1, I will move the decimal point one step further away from home. And I end up at 689.2 times 10 to the first power. That first power says that I've made one step away from home. From there I can move one more step away from home, shown by the fact that we are now 2 steps from home, and our number reads 68.92. From here I can take another step away from home, and I end up 3 steps from home, and the number is written 6.892. So if you want to raise the exponent from the home number, you move the decimal point away from the original spot, and you change the exponent value for every place that you move. In conclusion, you should observe that all of these numbers are the same number, just written to a different power of 10. Here we will show you an example of starting away from home and then moving the decimal point back home. Notice that at home the decimal is in its normal spot. And by the way, these are all the same numbers, just written to a different power of 10. The exponent just means how far or how many steps you are away from home. Here we are 3 steps away from home, 2 getting closer, 1 step very close to home, and 0 we are home at our normal decimal place. Let's begin by moving the 3 to 1 step closer home. To do this, we're going to move the decimal 1 space to the right, which is closer to home, and the exponent will change to a 2, and the number will be read 68.92. You can move the decimal point on 68.92 1 step closer to home, and this will be indicated by the exponent here, which is 1 step from home. At this point we are 1 step from home, and to get it home we can move the decimal point 1 place to the right and end up at home with a 0 exponent. Bottom line, moving the decimal further away from home will make a larger exponent. Moving the decimal closer to home will make a smaller exponent. So we will manipulate the exponent to get the powers of the 10 the same before we add or subtract. Examples with addition. In this example, write them this way and notice that the exponents are different, so we're going to have to change. I'll choose the bigger one and make it smaller. To do this, I want to move the decimal point 1 step closer to home and rewrite it as 92.4 times 10 to the 4th power. Now that both numbers are in 10 to the 4th power, we can add them. We get 99.29 times 10 to the 4th power. This has to be rewritten in scientific notation to move the decimal behind the first number. We need to move the decimal 1 spot away from home, which will increase this 4 to a 5. Our answer ends up being 9.929 times 10 to the 5th. Now you try this one. In this case, the exponent 4 needs to move 1 step closer to home to become a 3. Once this is accomplished, we can now add. Notice that we do not add the exponent powers. We end up with 28.93 times 10 to the 3rd. We have to rewrite this in scientific notation by moving the decimal 1 place to the left behind the second number. Moving away from the home placement of the decimal will raise it to the 4th power, and you end up with 2.893 times 10 to the 4th. Let's talk about subtraction. We use the same process, noting that the 8 is larger than the 7, by moving the decimal point one step closer to home. So it will only be 7 steps away from home. This results in a rewrite of 78.3 times 10 to the 7th. Note that I covered the 1 with the 0 to prepare for decimal subtraction. So the first step is to borrow from the 3 to make the 0 a 10 and subtract to make a 9. Next, we cannot subtract 6 from 2, so we borrow from the 8 to make the 2 a 12 and subtract 6 from 12 and get 6 with a decimal point. And now 1 from 7 should be 6, and 7 remains. So far the answer is 76.69 times 10 to the 7th, but we need to change this into scientific notation by moving the decimal right behind the first number. So we have to move the decimal point one more step away, or making it bigger. So our answer now becomes 7.669 times 10 to the 8th power. And that's it. Now you try this one. In this case, we're going to take the exponent of 9 and reduce it to 7 by bringing it 2 steps closer to home. Notice that I added a 0 to cover the 5 for decimal subtraction. After subtraction, we end up with 124.5 times 10 to the 7th. We are going to have to write this in scientific notation by moving the decimal 2 spaces to the left, which is 2 more spaces away from home, making the exponent grow 2 spots. So our final answer is 1.245 times 10 to the 9th. Enjoy.